Right, this is video 9.4. We're doing theoretical probability. So theoretical probability is what should happen. In a perfect world, theoretical stuff is what would happen, although most of the time in the real world, that's not exactly what's going to happen. So theoretical probability, if whatever you're playing with are fair, which means that every outcome is equally likely. So if you're rolling a set of dice that is a fair die, then you're just as likely to roll a 1 as a 2 as a 3. Now, sometimes they talk about having weighted dice where they're always flipped to the same number, and that would be an unfair outcome. So theoretical probability assumes that the whatever you're playing with is fair. So if there are n likely outcomes in a sample space, so however many likely outcomes there are, that's with a dice, you've got 6 likely outcomes. With a quarter, you've got 2 likely outcomes. So that's going to be your sample space. If you have that many that are likely to happen, then the probability of each outcome is just going to be 1 over n being the number of likely outcomes. And so if you're talking about a specific type of event, like getting heads versus tails, or if, let's say, you were throwing a handful of coins and you were wanting to get all heads out of all 5 coins, then the number of outcomes in that event would be the probability for the event. Let's do some examples. So let's say we have an experiment that consists of rolling a die that's fair, and there are 6 possible outcomes. You can get a 1, a 2, a 3, a 4, or a 5. Okay, so there are 6 possible outcomes. This 6 is going to be our n. So what is the probability of rolling a 3? Well, there's only one 3, so the probability of rolling a single event is going to be 1 over n. In this case, our n is 6, so we would say 1 over 6. What's the probability of rolling an odd number? So now we need to look at all the odd numbers. So there's a 1, a 3, and a 5. So that's 3. It's going to go on top, the number of events, over our n, which is 6. And then we would just reduce that down to 1/2. So you have a probability of a 0.5 of rolling an odd number. What's the probability of rolling a number less than 5? So in that case, we need to look at everything that qualifies in that. So a 6 is not less than 5, so we're not going to count that. A 5 is not less than 5, so we're not going to count that. But 1, 2, 3, and 4 are. So we would say that that is 4. We're going to put it over our 6. Reduce that down to 2/3. So you have a 2 in 3 chance, or about 0.66 chance in rolling a number that is less than a 5. Let's say we have 2 fair dice that we're rolling. So first we're going to figure out what the sample space is for the equally likely outcomes. So what I've done is I'm going to say that one die is going to be red and the other one is going to be black. And let's talk about what they are. So let's say that our black die rolls a 1. Our red die could be a 1, a 2, a 3, a 4, a 5, or a 6. Okay, so those are if the black die was a 1 and the other one was any of the other numbers. Say the black die was a 2, the black die was a 3, the black die was a 4, the black die was a 5, and the black die was a 6. So this could be all of the pairings you could have when you roll these 2 dice. So how many are there all together, are likely outcomes? To count them all up, we would say that n is 36. There's 36 likely outcomes that you could get from rolling 2 fair dice. So what's the probability of rolling doubles? Well, let's go back and look at it here. Let's see where our doubles are. We've got a 1, 1, a 2, 2, a 3, 3, 4, 4, 5, 5, and 6, 6. So how many is that? There's 1, 2, 3, 4, 5, 6. So that would be 6 over 36. Which is 1/6. You have 1 in 6 chance of rolling a double. What's the probability that the dice shown has a total of 10? So let's count up which those are. So that would be, let's see, that one's a 10, and that one's a 10, and that one's a 10. Don't see any others, so the chances are 3 in 36, which is 1 in 12. You're more likely to roll a double than you are to roll dice that add up to a 10. What's the probability that the total shown is less than 5? So, see, this one's less than 5, less than 5, less than 5. Only those. All the others are 5 or greater. So that would be 6 and 36, which is 1/6 chance. 1 in 6 chance of rolling a total that is less than 5. So let's say you're playing a game where the events are mutually exclusive. So you could say, what's the likelihood that you roll a double that equals 11? Well, you can't roll a double that equals 11. Those two are going to be mutually exclusive. They knock each other out. Okay, so that's what mutually exclusive means. So let's say we're playing a game of Monopoly and we've rolled doubles 2 times in a row. If you roll doubles again, you're going to go to jail. If you roll a 3, which wouldn't be a double, you would also go to jail because you're 3 spaces away from the go to jail square. So what's the probability that you will end up going to jail? So remember, our probability of rolling doubles was a 1 in 6, right? And our probability of rolling a 3 would be if you had a 1-2 or a 2-1. Okay, so you got 2 chances there to roll a 3. So let me put this back at the 36. There's 6 and 36 chances of doubles, and then there's 2 and 36 chances of rolling a 3. So altogether, we would say there are 8 and 36 chances of rolling a double or a 3. So we would just add those 2 probabilities up to get our probability of going to jail. And when we reduce that down, we can reduce it by a 4. All right, so if we reduce that by a 4, we would end up with a 2/9. So you got 2 in 9 chance, which if we take that and we make that a fraction, would be 0.22. So 22% chance that you're going to go to jail on your next throw of the dice. Go ahead and click on the link and do the homework, and I will see you in class.